Welcome to my YouTube channel, and if you are new to this channel, please click on the subscription button to get more videos on how to unlock the secret to maths and physics. And if you are having challenges with any questions or topic on physics or maths, you can write it on the comment section so that I can be able to treat it on my next video. So today we'll be talking about motion under gravity, free fall. It's a common experience that when an object, e.g. a stone, is thrown upward, it rises to a particular height and then falls back to the ground. When an object is thrown, it experiences two movements. One is the upward movement, and secondly, the downward movement. When an object is thrown upward, it experiences retardation due to gravitational attraction of the earth, which tend to pull the object downward. At that point, acceleration will be equal to negative gravitational force because it is in opposite direction to gravity. At the same time, the stone will gradually lose speed as it moves upward until it comes to a rest briefly. At that highest point, the final velocity is 0. And it begins to fall downward. That is the downward movement. And as it falls, its speed increases because of acceleration due to gravity. And what is acceleration of free fall? Acceleration of free fall due to gravity is the force of attraction of the earth on a unit mass. Let's represent what I'll be saying on a diagram. Let's see if an object is projected from the ground state. Its velocity, it loses velocity until it gets to a certain point and begins to fall downward to the ground. At this highest point, final velocity is equal to 0. There is something you need to know about this thing. When the velocity is increasing, it's moving upward. The object is moving upward. Maybe at this point, the final velocity is not equals to 0. Not equals to 0. At this point also, final velocity not equals to 0. But at the highest point, the final velocity is equals to 0. And when it is returning downward, because at this place, it is at rest. At the final point, it is at rest. The initial velocity of the body coming down will be equals to 0. While the final velocity can never equals to 0. You see, these are the things you need to know on this velocity, on this upward and downward motion of an object. And the equation used in this motion under gravity is also the same as the equation of motion, the four equation of motion. 1, V is equals to U plus AT. Then S is equals to U plus V over 2 times T. Then S is equals to UT plus half AT squared. And the fourth one, which is V squared, is equals to U squared plus 2AS. 2, 3, and 4. These four equations are what we will still use in motion under gravity, where S, which is in distance, will now be equals to H, which is height. Then acceleration will now be gravitation. Acceleration will now be equals to gravitational force. Let's come back to this diagram. When the object is moving upward, it will have initial velocity, and the initial velocity will be given. When it is moving upward, it's in opposite direction to gravitational force. Why? Because when any object that is thrown upward must return downward. And that downward motion is positive, while the upward motion is negative to the gravitational force. So acceleration in the upward motion, so acceleration in the upward movement will be negative gravity, while in the downward movement, acceleration will be positive gravity. These are the things you need to know before you can calculate any question relating to equation under gravity. And as I told you earlier on equation of uniformly accelerated motion, that the three parameters must be given, or let me just say, three parameters will be given, and you will choose from these four equations the one that will best suit the question. So let's go to question 1. Question 1. A cricket ball is thrown vertically upward with an initial velocity of 40 meters per second. Find 1. The velocity after 3 seconds. 2. The maximum height attained and the time taken to reach it. 3. The total time taken for the ball to return to the ground again. Neglect air resistance. Let's bring us the given parameter. Given. The cricket ball is thrown vertically upward. That is, initial velocity is equals to 40 meters per second. Find 1 velocity, its velocity after time 3 seconds. 2. The maximum height attained and time to reach it. 3. The total time taken for the ball to reach the ground again. Total time taken to return to the ground. Let's draw the diagram for this question. Let's say here is the ground state, and a cricket ball is projected upward until it reaches the height, then return to the ground state. In this upward movement, we have initial velocity to be 40 meters per second. Then we are asked to calculate the velocity at time 3 seconds. Let's assume here to be the time 3 seconds. Time is equals to 3 seconds. Therefore, velocity at this point is unknown. That is question 1. From the given parameter for question 1, we have V, which is the one we are looking for. We have time, 3 seconds. We have initial velocity, which is 40 meters per second. And we have acceleration, which is equal to negative gravity, which is negative 10, since it's moving upward. So we will check out the four equations of motion, which are V is equal to U plus AT, S is equal to U plus V over 2 all over time, S is equal to UT plus half AT square, then V square is equal to U square plus 2AS. We look at the parameter given and compare it with this equation. We have, if you look at equation 1 now, we are looking for velocity. We have initial velocity, we have acceleration, and we have time. With this equation 1, we can find the final velocity. So velocity is equal to U plus AT, which is equal to U is 40 plus bracket negative 10 times 3. We have 40 minus 30. We have 10 meter per second. This is our velocity at time 3 seconds. Let's go to question 2. In question 2, we are asked to find the maximum height and the time to reach the maximum height. We said that at the highest point, where it return downward, velocity is equal to 0. And we are asked to calculate the maximum height to reach it. With the given now, we have V equals to 0. We are looking for the height. We have initial velocity equals to 40. We have acceleration equals to negative g, which is minus 10. If you compare this parameter with this equation now, we will see that we have V, we have the initial, we have acceleration, and we are looking for the S, which is the height. Since we don't have time, we cannot use this equation. So we use this equation to calculate for height. From the equation, we have V square is equals to U square plus 2AH, which is V square is equals to U square minus 2G, because it's moving upwards, negative gravity. So times the height. When you impute the value, we have 0 square is equals to 40 square minus 2 times 10 times the height. 0 square 0 is equals to 40 square 1600 minus 2 times 10, we have 20 height. Move this 1600 to this left side, we have 1600 is equals to 20 height. Therefore, our height is equals to 1600 divided by 20. We have 2 divided 16, we have 8, and become 80 meter. This is for question 2, the maximum height. And we are asked to find the time to reach it. So we are also asked to find the time to reach the maximum height. We know that the final velocity is equals to 0 and acceleration is equals to negative, which is 10. So that initial velocity is equals to 40. We have to find time. If you compare this parameter with this equation now, know that you can find time using this equation 1. Now be V is equals to U plus AT, which is V is equals to U minus GT. Since it is an upward movement, we now have V, which is 0, equals to 40 minus 10t. Move this one to this other side, we have 40 is equals to 10t. Therefore, time is equals to 40 divided by 10 is equals to 4 seconds. And the last question, which is the total time taken to return to the ground. To calculate for the total time taken, we will consider two times. The upward time, let's say, is t1, and the downward time, let's say, t2. And this value is equals to t1 because it's an upward movement. Let's consider the one of downward movement. For the downward movement, it's falling down from rest. Initial velocity for the downward motion will be equals to 0. So from here now, no initial velocity is equals to 0. We have the height is equals to 80. There's no velocity, no final velocity, and we are looking for the t2. We also have acceleration, which is positive gravity, which is equals to 10. From this parameter now, then we look at the equation. We know that we have s, which is the height. We have initial, which is equals to 0. We have acceleration, which is positive gravity. We are asked to look for time, which is what we are looking for. It will now be s is equals to ut plus 1 all over 2 gt2 square. From here, now have at, which is equals to the height, is equals to initial 0 times time plus 1 all over 2 times 10 times t2 square. Now the at is equals to 0 plus 1 all over 2 10 times t2 square. This here 1, this here 5 becomes 80 is equals to 5 t2 square. Therefore, t2 is equals to 80 divided by 5, which is equals to 80 divided by 5, we have 16. Therefore, t2 will now be root 16, which is equals to 4. Therefore, total time equals to t1 plus t2, which is 4 plus 4, which is equals to 8 seconds. That is for question 1. Let's go to question 2. Question 2. A ball is released from a height above the ground. Find its velocity after 5 seconds. Take g equals to 10 meters per second square. Let's draw the diagram for the given parameter. Let's say given let's say here is the height above the ground, and the ball is released the height to the ground. And here is the ground. From our previous explanation, we say that when a ball is released from the race, u is equals to 0. And since the ball is going downward, acceleration becomes positive g. The time taken for the ball to reach the ground, t, is equals to 5 seconds. And we are asked to find the final velocity, v. From the given parameter, if you compare it with the 4 equations of motion, you will see that we have initial velocity, which is this, we have acceleration, which is this, and we have time, which is this. And we are asked to find velocity, which is this. Question 1 is the best to use for this question. Therefore, v is equals to u plus at. Therefore, v is equals to u plus gt, where u is given as 0 from rest, 0 plus the gravity. We are asked to take gravity, take g is equals to 10 meter per second square. So it will now be 10 times the time, which is 5. Therefore, 10 times 5, the final velocity will now be 50 meter per second. That is for question 2. Let's go to question 3. Question 3. A ball thrown vertically upward from the ground level hit the ground after 4 seconds. Calculate the maximum height it reached during the journey. Let's draw the diagram for the question. Assuming here to be in graph state, the ball was thrown vertically upward to attain a maximum height and then return to the ground state in time 4 seconds. From here now, at the highest point, we have velocity equals to 0. Let's assume that the time for the object to reach the maximum height is t1. And t1 is half of the total journey. Therefore, t1 is equals to the total time divided by 2, which is 4 divided by 2, we have 2 seconds. For the upward motion, we also have acceleration is equals to negative g. And we are asked to calculate the maximum height where initial velocity is not given. And from this parameter now, we can use this equation 3 to solve the height. But initial velocity wasn't given. So we can use equation 1 to get the initial velocity, since we are only considering the upward movement. From the upward movement, we have v is equals to 0. We have time is equals to 2 seconds. We have acceleration is equals to negative g. So we are asked to find u, which is not given. So from the equation 1, we have v is equals to u plus at, which is equals to v equals to u minus gt. And we have the final velocity, which is 0, is equals to the initial velocity, what we are looking for, minus the gravity 10 times the time to reach the maximum height, which is 2. Therefore, when you move this to the other side, u will now be 10 times 2 will now be 20 meter per second. So we have gotten our u, and we'll use equation 3 to solve for the maximum height. Therefore, we have h is equals to ut minus half gt squared, which is equals to our initial is 20 times the time 2 minus 1 all over 2 times 10 times the time square. So we have 40 minus 1 all over 2 times 10 times 4. This here we have 1, this into 4 we have 2. Therefore, we now have 40 minus 20. Therefore, height will now be equals to 20 meters. That is our answer for question 3. Let's go to question 4. Question 4. A ball is projected vertically upward from the top of a tower 60 meters high with a velocity of 30 meters per second. What is the maximum height above the ground level? And how long does it take to reach the ground level? Let's draw the diagram from the equation. Assuming this is the height of the tower from the ground level, which is 60 meters, and a ball is projected vertically upward with an initial velocity 30 mm to a certain height and a return to the ground level. Initial velocity is equal to 30 meters per second. While at the highest point, we say that the final velocity is equal to 0. And since the motion is in upward direction, A is equal to negative G. From these three values, we can find the height from the top of the tower to the maximum height. Let's say here is H1. And we are asked to find the height from the ground, which is H. For us to get the height from the ground, H is equal to H1 plus the height of the tower, which is 60 meters. Firstly, we'll find H1, then impute the value of H1 into this equation to get our height. From the three values, let's say V is equal to 0, A is equal to negative G, and initial velocity equals to 30 meters per second. And H1 is what you are looking for. From these four parameters, we can use equation 4 to get our H. From equation 4, we have V squared is equals to U squared minus 2GH1. Our V is equals to 0, which is equals to our initial is 30 squared minus 2 times 10 times H1. Therefore, we move this one to this side, become, and 30 squared is 900, will now be 900 is equals to 2 times 10, 20 H1. Therefore, H1 is equals to 900 divided by 20. 0 cancel 0. 2 go into 9, we have 4, 45. So, we have H1 is equals to 45 meters. Therefore, to find our height from the ground level, which is equals to H1 plus 60, we now have 45 plus 60, which is 105 meters. To calculate the time taken for the ball to move from the top of the tower and return to the ground state. First of all, we'll calculate the time taken for the ball to move upward from the top of the tower to the highest point. Let's take it as T1. And the time taken for the ball to move from the highest point downward, let's take it as T2. Therefore, the total time will be given as T is equals to T1 plus T2. And before we can do that, we have to find T1. Using this value, V is equals to 0. Also have A is equals to negative G, and initial velocity is equals to 30 meters per second. From here now, we can find our T1. If we consider this parameter, we can use equation 1 to find T1, which is V is equals to U minus G, since it is moving upward, times time, times T1. Therefore, 0, which is our final velocity, is equals to U 30 minus 10 times T1. Move this to the other side because 30 is equals to 10 T1. Therefore, T1 will now be 30 divided by 10. We have 3 seconds. And for us to consider the one of T2, we know that when an object is returning from the highest point, the initial velocity is equals to 0. And acceleration will be positive G because it's coming downward. From here now, we can find our T2 from this given value. And we have the height from the highest to the ground state. Let's say we have height which is equals to 105. We have U which is equals to 0. We have A which is equals to plus G. And T2 is what we are looking for. From here now, we can use equation 3 to find our T2. Therefore, it becomes H is equals to U times T2 plus 1 all over 2 G T2 squared. And H is equals to 105 is equals to U, the initial velocity, which is 0, times T2 plus 1 all over 2 times 10 times T2 squared. Therefore, 105 is equals to, this time this is 0. Here we have 1, here we have 5. It becomes 5 T2 squared. Therefore, T2 squared is equals to 105 divided by 5. It becomes 21. Therefore, to find T2 is equals to root 21, which is equals to 4.58 seconds. Therefore, our total time is equals to T1 plus T2, which is 3 plus 4.58, which is 7.58 seconds. And that is our total time it took for the ball to return to the ground state. And that will be the end of this class. Our next class will be motion in an inclined plane. Please click on the subscription button to get the next video. Thank you.